Example 8, an airline pilot sights a life raft at a 26-degree angle of depression. The airplane's altitude is 3 kilometers. We're going to draw a picture and then find the airplane's horizontal distance from the raft. Okay, so again, you do not have to have any drawing skills at all. But I sometimes do, I don't sometimes have drawing skills. I'm saying I sometimes draw pictures so I can get an idea of what's going on. So I have my airplane up in the air, and then there's supposed to be some life raft. So here's my stick person asking for help, not drowning. Okay, so this is what's going on. It says the pilot sees the life raft at a 26-degree angle of depression. Now, it makes sense that it's a downward angle because the plane is up in the air. They would have to see the person in the water downward. However, we have to be careful. It has to be down from a horizontal line, which means this airline pilot is going to keep flying horizontally. But instead, though, they didn't see the person up here. They looked down, and that's when they saw this life raft. So that is where the 26-degree angle goes. The convenient thing, this horizontal distance here, up, meaning if the life raft wanted to see the airplane, it's also 26 degrees. And the reason I mention that is, this is all well and good to label a plane and a raft and whatever, but if you don't have the right triangle, there's not a lot you can do. You have to have a right triangle. And that's the way most people like to draw the triangles. Like I'm saying, you could draw a triangle up here. That tends to mess with most students' heads, so I don't do it that way. Usually I will draw some type of right triangle that either looks like this or looks like this. So I did it this way, and that's the reason that this 26 is here, because the 26 is here and they're always going to be the same. Then it also told me the altitude of the plane was 3 kilometers, which is the height. We're supposed to be finding the horizontal distance, which does not mean this. This is not horizontal, because it's not like the plane's going to suddenly readjust their route and go and dive bomb this raft. It's just saying, what's this horizontal distance so they can report the location, presumably somebody to rescue it. So, it's a right triangle. The hypotenuse is not labeled, because like I said, I don't need to know that dive bombing distance. But from the angle in my triangle, because please note, this angle is not in the triangle. We've moved it inside. That angle out there is just kind of out there. It's not really anything I'm going to use. You'll notice it's not here. I don't currently have a label for this angle. Don't use that spot. From this angle inside my triangle, the x is adjacent to it, while the 3 kilometers is opposite from it. So again, we have a tangent ratio. So tangent of my angle is equal to the ratio of the opposite leg over the adjacent leg. We're finding a side, so I'm going to cross multiply. 3 times 1 is 3. X times the tangent of 26 is x times the tangent of 26. And I will find x by itself by dividing by the tangent of 26. So that's what I got to go to my calculator for. And I'm getting 6.15. So that would be how many kilometers horizontally they are away. And again, drawing skills are unnecessary. The only thing you do need to have, so like your plane drawing skills, your water drawing abilities, your stick person abilities, if you can do this much, you're going to be fine. I put the extra in because I like giving the context of the problem, but you don't have to. So let's do example 9. You sight a rock climber on a cliff at a 32-degree angle of elevation. Your eye level is 6 feet above the ground and you are 100 feet from the base of the cliff. we're going to find the height of the rock climber from the ground. So this one's going to be a little bit different. So here is the rock, and here is my rock climber. There we go. Again, stick people, unnecessary. And you are the one citing this, so you are not standing right underneath this person. You are some distance away, so I'm actually going to draw you. You're waving to yourself. This is you. Okay, so you see this rock climber. You could look horizontally, but then you wouldn't see him. From that horizontal line, you have to look up at this person. That is where the angle goes. So you do have a right triangle. What I want to point out though is, I'm telling you that for some of you, you had a growth spurt. Your eyes are 6 feet above the ground, which means this distance from here to here is 6 feet. This distance from here to here is 6 feet, which is important because in the end, I want to know how high this rock climber is off the ground. I'm going to call it H for height. And if you just say, oh, X is his height, you're wrong. Let's pretend X turns out to be 100. I made that number up. If this rock climber falls, they don't stop at 100 feet. They have 6 more feet still to fall. So we are going to have to add X and 6 in order to get our total height. And the last thing on here, you are 1,000 feet from the base of the cliff. When you're hearing how far from something you are, it's not talking about from this rock climber. It's saying from the base, from the bottom of the cliff. So this is our horizontal distance. We have 1,000 feet. And I'm writing this gigantic because this bottom horizontal is 1,000 feet and my dotted horizontal is 1,000 feet. So it doesn't really matter where it is, so I kind of wrote both places. So if I'd like to know what X plus 6 is, I got to know what X is first, so I'm going to do that. And I have an acute angle, and I can figure out that X is on the other side of the triangle from it, so it's the opposite leg. 1,000 is right next to this angle, so it's the adjacent leg. And again, we don't care about the hypotenuse. That's not really a coincidence. When you do real life problems, you typically don't have that slanted distance. It's not something that's easy to measure. So don't think it's weird if you get a bunch of tangents in your problems. Okay, so I'm going to cross multiply because I'm finding a side, and this is not one where I'll have to divide because as soon as I cross multiplied, I got X on its own. So all I need to do is put that in my calculator. And I'm seeing 624.9-ish. And again, that's just X. I want the height of the rock climber off the ground, so I need 6 more than that. So I'm going to say the total height is that 624.9, that first part of the triangle, plus 6 more. Why was that not working? Plus 6 more feet for the rest of the, like, the rectangle at the bottom of the triangle, I guess you could say. So he's about 631 feet up in the air. That's our